This assessment asks us to suggest a mechanism for the intramolecular aldol condensation reaction. We'll start by using sodium hydroxide to deprotonate an alpha proton to form an enolate. That will form an enolate. 3, 4, 5, 6, 7. They'll form an enolate which can act as a nucleophile which can attack this aldehyde. So we'll take a lone pair of electrons from oxygen, drop them back down to reform the carbonyl. The enolate carbon can attack the aldehyde carbon on the other side of the molecule. That builds up too much electron density around carbon, so we'll break the carbonyl pi bond and deposit those electrons onto oxygen. Let's go ahead and number these carbons to make sure we get everything in the right place. So at least as I've numbered it, we're going to form a new bond between carbon 6 and carbon number 1. That's going to form a new 6-atom ring with a new bond between carbon number 6 and carbon number 1. 1 is still attached to 2, 3, 4, and 5. 6 is attached to 7. And 1 now has an alkoxide, an O- charge. We can use some water to neutralize this O- charge. Lone pair of electrons on oxygen. We'll grab a proton from water. Let me draw that out a little more explicitly. So I can show the bond breaking to oxygen. That forms the traditional aldol addition product. Since we have added heat in this reaction, we'll continue on to do the aldol dehydration. So we'll remove this hydrogen with more hydroxide to form another enolate. And then we'll use those electrons on oxygen to start the sequence where we eliminate hydroxide from carbon number 1, and that will form our final product of this reaction. This is the mechanism for the intramolecular aldol condensation reaction.